A research facility in Hefei, China, has successfully contained a fusion reaction hotter than the core of the Sun for a record-breaking duration. The experiment involved a massive magnetic containment vessel, often referred to as an artificial sun, which managed to sustain a temperature of 100 million degrees Celsius for 1,066 seconds. This nearly 17-minute burn represents a significant leap from previous records measured in mere seconds, signaling that controlled nuclear fusion is transitioning from a scientific theory into a practical energy solution. The process of nuclear fusion mimics the internal mechanics of stars by forcing light atomic nuclei together to release immense amounts of energy. Unlike traditional fission, which powers current nuclear plants, fusion offers a virtually inexhaustible fuel source derived from seawater. Scientists estimate that the fuel extracted from a single liter of ocean water can generate energy equivalent to 300 liters of gasoline. This breakthrough suggests a future where global energy crises and conflicts over oil reserves could become obsolete, as the fuel required for fusion is abundant enough to power civilization for billions of years. Achieving this holy grail of energy required overcoming immense technical hurdles. Because no physical material can withstand temperatures of 100 million degrees, Chinese researchers utilized a tokamak design, which uses powerful magnetic fields to suspend the swirling plasma in a vacuum, preventing it from touching the walls of the reactor. This delicate balance was maintained through the use of advanced artificial intelligence capable of adjusting magnetic fields in fractions of a millisecond. The project involved 15 years of experimentation and the precise assembly of nearly 1 million individual components. Beyond the immediate energy implications, this advancement highlights the rising strategic importance of specific high-tech materials. The demand for high-temperature superconductors, which create the necessary magnetic fields without electrical resistance, is expected to surge. Furthermore, the reactor's inner lining requires tungsten, the metal with the highest melting point on Earth. As China holds approximately 80% of the world's tungsten reserves, the shift toward fusion energy could transform this industrial metal into a critical strategic asset. Looking toward the future, the success of the East and Huanliu projects suggests that the era of fossil fuels may eventually give way to a new age of exploration and abundance. Experts predict that by the year 2035, next-generation fusion engineering projects will be operational. This transition promises to lower the cost of electricity to negligible levels, potentially enabling massive environmental projects like large-scale seawater desalination and the greening of arid deserts. Ultimately, the blue flame of controlled fusion represents more than just a power source. It is a gateway to the stars and a new chapter for human civilization.